I'm just going to do a quick check-in of who I don't think I have in here yet. So, and then I'll also make sure I can see everybody's faces too. Okay, so let's see. Just a quick look. Natalia, can I see you real fast? Everybody, I just need to see your faces real quick, and then we'll move on to the next part of the meeting. Thank you, thank you. Let's see, Jeanette, I saw you earlier. Good, you're good, thank you. Let me see, next page, make sure I can see everybody. McKenna, I don't, oh, there you are, good. Natalia, Myri, I think I have seen everybody else. Natalia and Myri, are you guys able to turn on your video? Everybody, oh, thanks Myri, I gotcha. And then, oh, there's Natalia, gotcha, okay. So I think I've seen everybody that's in here now. Oh, Ashlyn, is that a little sister or a little brother? Who is that?
He's a roommate.
What's that?
He's a roommate.
Oh, what a cutie.
Can you say hi?
Hi.
Say hi.
What's his name?
His name's Emmett.
Emmett. Hi, Emmett. Okay, so real quick. I don't see Caleb, Aiden, Jaden. Hi. Ian, Wendy, Natalie, Abel, Rose, Marley, Sadie, Dorian, Dwayne, David Ezor, Jimena, Udani Kanisiana, Madison, not Maddie Martinelli, but Madison Hodgson, Jordan, Chuck, Valerie, Eric, Katie. Okay, I think I got everybody else. Okay, okay, this is gonna be super distracting with the cute little baby to look at. Okay, just kidding. Okay, so this week I thought I would mostly spend some time kind of talking about the lesson this week. So if you want to have your notes in front of you to add to your notes, you can. I actually will go over a few of the practice assignment problems also. So if you want to make sure you have that nearby too, those are things that I want to make sure to talk about. It was a long lesson this week, and it has a lot of stuff that we really haven't talked about at all yet this year. And some of this stuff may be things that I think, you know, some people may have seen it in middle school and some people may not have. And so there's just a few things that I want to make sure to address today. So real quick, like I just wanted to talk to you guys about some area formulas that you should know. And again, if you didn't see it in a math class before this, it is not your fault, but I want you to kind of write this down if you don't have it already. Some of these things you saw already in the lesson, but I just wanted to kind of reiterate. So just real quick, the difference between area and perimeter. Area is like the space that fills something up. So like if you were coloring something in, it's like how much gets colored in. Whereas perimeter is just the distance around something. So just measuring all of the sides and then adding up the lengths of all the sides. So that's the difference between area and perimeter. When we talk about circles, circles don't have perimeter, they have a circumference. And again, the circumference is like the perimeter, it's the distance around. So if you had to find the perimeter of a rectangle, the perimeter of a rectangle would be just adding up each of the sides. And so I'm not even going to write it down. It's just going to be add all the sides. Okay, if it was a rectangle, if it was a triangle, if it was any shape at all, a perimeter you can find by just adding up all of those sides. I need to mark that I've got Wendy here now. Okay. And then for the circle, the circumference, which again is like the perimeter because it's the distance around, it is 2 pi r. And then keeping in mind that that pi is a symbol that means 3.14, 1519, and there are probably some of you guys that know a lot more digits of pi, but it is a decimal that goes on forever. And anytime you are doing the practice assignment and you have to get the decimal approximation, you should use the pi button on your calculator, right? So the calculators all have a button with pi on them. Mine is the little blue one up above that there. Okay, so that's perimeter and circumference. And then when we talk about area, there's a bunch of different formulas for area I want to make sure you guys know. So if it's a rectangle, the area of a rectangle is just the length times the width. And I always will use a cursive L for length because otherwise it looks like a number 1. Okay, and so if you need to see a picture of that, if this is, let's see, if this is the length and this is the width, then the area you can find just by multiplying those two together. A triangle, the area is 1/2 the base times the height, and so I'll draw a picture of that down here. The base and the height have to be perpendicular to each other, and so if you have a right triangle, it's just the base and the height are the two sides that are on that make up the right angle. If it's a triangle that's not a right triangle, if you call this the base, then you have to figure out what that perpendicular distance is that's measured to the base there, right? So this here would be the height because it's perpendicular to what we've called the base, and you can name any side the base really, okay? So that's area of a triangle. For the area of a circle, it's, let me do A equals, that's pi times the radius squared, and the radius is just the distance from the center out to the edge. And then a polygon. This was something that I had to look up. This is not a formula that I use very often, so it's not something I think you should memorize. The other ones are formulas that are very often used, and so I don't know if you want to make flashcards and memorize them, but they are very useful to know. But a polygon is not one that gets used very often, but the area of a polygon, and a polygon is just it's a shape with any number of sides. So a triangle could be a polygon, a rectangle could be a polygon, a pentagon that has 5 sides is a polygon. Any number of sides makes a polygon. And so the formula for the area of a polygon, they actually told you, I think, in the video, is 1/2 of the apothem times the perimeter. And so I'm going to talk about what the apothem is, because I don't think that they did really talk about that. And it is something that comes up in a couple of the problems. So an apothem is a line from the center of a polygon at a right angle to any of its sides. So I'm just going to draw a hexagon real quick so that I can show you what an apothem would look like. So from the center, the apothem is the perpendicular distance to any of its sides. Okay, and again, that is the apothem. That P stands for the perimeter. Okay, so the perimeter would just be the distance around, right? So I would add up each of the sides to figure out the perimeter to that shape. So if this was 5 and this was 5, I would add 5, 10, 15, 20, 25, 30 to get the perimeter of that, right? So that's how you find the area of some of those shapes. Something else that is kind of assumed that you know in the video is if you have a circle, again, the radius is the distance from the center to the edge, but the diameter is all the way across and going through the center. Okay, so the diameter goes all the way across, whereas the radius just goes from the center to the edge, which means that if you have 2 radiuses, that will make up the diameter, right? If I had a radius here and a radius here, then I have 2 radii. It's actually radii is equal to the diameter. Okay, now let me make sure I got that Chuck is here. Chuck just came in. Okay, and then let's see. They talk about, I can't remember the guy's name, but the guy in the video, he talks about something called a net. And so if you want to go back and rewatch that part, a net is when they take a shape and they unfold it and make it two-dimensional. So I think he ends up doing something that looks kind of like this, right? And that's called the net. So when you unfold, 1, 2, 3, 4, I think that's too many sides. Anyway, when you unfold a shape, you end up with the net. And you don't have to do that, but I think the net is helpful because instead of using all the formulas that he gave you for the surface area is the area of each of the surfaces. If you could find the area of this and the area of this and the area of this and find the area of each of those rectangles, then the surface area is just what you get by adding them all together. So if you can picture what the net looks like, it might be easier to figure out the surface area by thinking about what the net looks like and then finding what the area of each of those faces would be. So you might find that helpful because sometimes those formulas get just a little bit tricky. So all right, so I think that was pretty much it about the lesson. Like I said, I do want to go over, I'm going to go over 3 problems completely, like beginning to end, and then I'm going to talk about another one just to kind of make sure everybody's clear on it. But before I get to that, did anybody have any questions on the lesson that you would like me to address before I get started with going over the homework? Okay. So I will just say again that I know sometimes those videos go real fast and I usually have to pause them so that I can get stuff written down. There were a lot of formulas given to you there. So if you didn't get those formulas completely written down, you should make sure you go back and rewatch it so that you can get that written down. So let me share my screen then with the homework. Today I'm only going to be talking about the lateral area and surface area problems from this week's lesson, but I just want to remind you guys, if there is stuff that you're struggling with, like the trigonometry stuff that we did in the past, it is super important, that trigonometry stuff, to make sure you understand it for future math classes, especially if you're thinking about taking the accelerated math 3 class. And so it would be worth going back and maybe rewatching videos. Definitely come and see me during office hours so that I can help kind of clarify some things for you if there's anything that you're still stuck on there. So just kind of keep that in mind. Okay, so let's see. I would like to go over number 2. So if you have your homework in front of you, you could do that with me right now. I call it homework, but it's the practice assignment because everything's homework right now, right? Anyway, okay, so the directions here are the lateral area, to find the lateral area. And the formula for the lateral area, and again, the lateral area is the sides not including the bases. Okay, so I'm going to take just a second to figure out what the bases are so that we can talk about what the lateral area is then. So remember, the bases are the faces that are the same shape and parallel to each other. So hopefully you can see there's a triangle here and then a triangle here. Those are your bases. Okay, so if I'm looking for the lateral area, I'm not going to include those triangles. I'm just going to be including the rectangles on each side. Okay, so that's what my lateral area is going to be. And again, if you think about the net, you might go, okay, well, I'm going to find the area of each of those rectangles and just add that together. And maybe that's easier for you because it doesn't really matter how you do it, right? Just that you do it. So the formula that he gives you for the lateral area is the perimeter times the height. And when it talks about the perimeter, that is the perimeter of the base. So that means I want the perimeter of one of those triangles. So I want to know the distance around one of those triangles. Well, I can see this is 5, I can see this is 2, but I don't know what this is, do I? Or do I? This down here is the same as this one up here. So this is also 6 kilometers. So I can tell the perimeter of that base there is 5 plus 2 plus 6, which gives me, what does that give me? 7 plus 6 is 13. So the perimeter of the base is 13. And then the height is the perpendicular distance between the two bases. And so that's that 4 there. So the height is the 4. And so my lateral area is going to be the perimeter 13 times the height 4. And I think that gives me 52. Please unmute yourself and speak up if I make a mistake. Says to round to the nearest 10th, but I don't need to round because it's exactly that. Actually, he, in the video, I know he said when it was round to the nearest 10th, he put a 0.0 to show that it was rounded to the nearest 10th. And then just quick clarification on the units. The linear units here are in kilometers. And so when I do the surface area, that's going to be square units because it's 2-dimensional. It has an exponent of 2 on the units. The next one I want to talk about is number 5. I'm not going to do the whole thing on number 5, but I do want to talk about what the bases are for number 5. And keep in mind too, if you're not able to write this down right now, this is being recorded. Oh God, I hope it's being recorded. I'm going to stop sharing for a second to make sure I'm recording. Yes, I'm recording. Whew, okay. And so you can go back later to see how to do these problems if you need to. So you can keep that in mind. Okay, on this one here, you are supposed to find the surface area. So that's all of the surfaces. It's the lateral area plus the bases. So I just wanted to take a minute to talk about what the bases are. You can see I put myself a little note there. What are the bases? So the bases, again, are the sides that are parallel to each other. They're the same shape and they're parallel to each other. So hopefully you can see there is this triangle here and this triangle back here, and those are the bases that are parallel to each other, okay? And then keep in mind, to find the surface area, you are going to use the formula. You're going to need the lateral area, like before, is the perimeter times the height. So you'll find the perimeter of one of those bases, and then multiply the height, which is the distance. Again, the height is the distance between the bases. And then you'll add to that the area of those two bases. So you could say 2b, and where b is the area of those bases. And because those bases are triangles, you are going to need to use 1/2 the base times the height of the triangle. Oops, slide that up so you can see it. Right, and so keeping in mind that here's a triangle with a right angle right here. So you could say that that's the base and that's the height, or that's the base and that's the height of the triangle, right? So you could say the base is 6 and you could say the height is that 8 there. Okay, and so that will hopefully help you to get the answer there if you need it. I wanted to go over 7 with you because 7 is one of those that has a polygon. And so wanted to talk about that. So you are supposed to find the surface area here in number 7. And so because I'm looking for the surface area, I do want to, again, find the perimeter of the base times the height plus 2 times the area of the base. So let me take just a minute to talk about what the perimeter of the base is. Okay, so the base, hopefully you can see, is this. It's a hexagon because it has 6 sides, 1, 2, 3, 4, 5, 6. That's called a hexagon. And so because it's a regular hexagon, which means it is all of the sides are equal to each other. The regular hexagon is has all the sides that are length 7. So since there's 6 of those sides that are length 7, that is the perimeter of that base is going to be 6 times 7 or 42. Then I need the height of the base, and the height of the base is the perpendicular distance between the two bases, and so that's that 5 right there. And then I need to find the area of the base, and so this is the tricky part, I think. So the area of the base I'm going to find using that crazy formula that I gave you, which was 1/2 of the apothem times the perimeter of the base. So we need to figure out what the apothem is. And that is this thing that they have labeled here. So that's the center of that bottom base there. At least that's the way I'm seeing it, is that's the bottom. And then perpendicular to the side of that bottom base there is this apothem that is the 6.1. So that apothem there is 6.1. And then times the perimeter of the base, which we already figured out the perimeter of the base was 42. Okay. And so let's see, did I do that right? Yeah. And so I got, when I had my calculator out earlier, I got that the area of that base, and again, that base is a hexagon. Oh, did my screen freeze? You guys need to speak up because I don't see that happening.
It's frozen.
Thank you.
Yeah.
Okay, let me get back to it. Hopefully it'll pop back up here. But I got the area for the area of the base is, and you'll see it here in just a second, 128.1. And again, I got that just by plugging this into a calculator. 1/2 times 6.1 times 42, and I got that 128.1. And so now I'm going to plug that and that and that all into the formula for the surface area. So the surface area is going to be the perimeter of the base, 42, times the height of the base, 5, plus 2 times the area of the base, which is that 128.1. And then when I plug that all into the calculator, well, maybe I'll leave that for you guys to finish. You can finish plugging that into the calculator to get a final answer for the surface area of that. It's called a hexagonal prism. Okay, it's a prism because it's got the two bases that are parallel to each other. And it's a hexagonal prism because the bases are hexagons. Okay. All right, let's see here. Sorry, I was looking at what was in the chat there. Okay, so the next one and the last one that I'd like to go over with you guys is number 9, and then I'll take other questions if anybody has other general questions after I go over number 9. So this is the first one on the back, at least the way I printed it, it's on the back. So this shape here is called a cylinder. And again, a cylinder is kind of like a can of soda or something, right? Where it's got circles on the top. So the bases are those circles, right? And then in the video, they talked about the lateral area, which is the area that goes around the shape, is actually ends up being a rectangle. Okay. And so if you were to like cut this and unroll it, it ends up being this rectangle kind of shape, where this length here on the rectangle is actually the distance around one of those circles there. And so that length right there is the circumference, which is 2 pi r. And they gave us the formula for that, so you don't need to write that down again. But if I wanted to find the surface area of a cylinder, I'm going to do 2 pi RH, and again, it's 2 pi r because of that, and then times h because of that, and that gives you the area, that gives you that lateral area there. So again, that's 2 pi RH, plus, because I'm doing the surface area, I have to add in the two bases, 2 times the area of the base. I'm going to erase the b there because these bases have a specific formula because they are circles, and the area of those bases, the area of a circle, is pi r squared. And again, it's really helpful to remember circumference is 2 pi r and area of a circle is pi r squared. Okay. So now let's figure out what each of these things are. Do we know what the radius of those circles are? Well, this has this labeled as 16 inches, but that's not the radius, right? That's going all the way across the center like through the center of the circle. So that's the diameter. So if I just wanted to know the radius, then I would have to cut that diameter in half. Okay, so my radius is 8. The height is the height of this rectangle here, right? Which is the height between the two bases. So that's that 9 there. And I think those are the only things we need to know. I can just plug everything in now. So 2 pi times the radius, 8 times the height, 9, plus 2 pi times the radius, 8 squared. And that'll give me my surface area. Okay. The directions here do say to leave in terms of pi and round it to the nearest tenth also. So you'll be circling 2 answers for me on this one. So what that means to leave in terms of pi is to figure out, well, what is this term here multiply to be? 2 times 8 is 16. 16 times 9 is 144 pi. Okay, so that's in terms of pi. Plus, and then this one over here, I'm going to do the exponent first. So I do the 8 squared first, and then that times 2. So 64 times 2, 128 pi. And then if I add those 2 together, that gives me 272, I think, pi. And then the units here were in inches up here. So because this is area and it's 2-dimensional, it's square inches. So that's my area in terms of pi. And then to figure out the area rounded to the nearest tenth, I'll actually use a calculator and make sure to use the pi button, right? So I'm actually going to type in 272 times, and I'll hit that pi button to get my answer. Okay. And so you'll want to make sure you write both of those answers in there, 854.5 square inches. So that's all I'm planning on going over, and I'm going to pause for just a second and see if anybody has questions for me before we sign off. So is there anything else in the notes or in that assignment that you guys would like me to talk about? What do you guys think? Okay, so I'll just remind you guys about a couple of things then. If you are stuck on anything, I do have office hours today at 3. And then if that's, if that doesn't work for you, there's tomorrow at 2 and Friday at 2 also. That's past the deadline when you're supposed to turn it in, but you can always just put a message into the assignment for me if you need help with anything. So that's no big deal. So let me know about that. And again, come see me at 3 o'clock today if you need anything. If the office hour times ever don't work for you, just send me a message. I can do it another time. I don't have a whole lot else going on, and I'd be happy to help you guys. So we can schedule a Zoom another time to help you if you need help on anything. So keep that in mind. So since nobody is jumping in with a immediate pressing question, I will go ahead and let you guys sign off. And then if you want to stick around and ask questions, you can, but please unmute yourself and turn your videos back on as you wave goodbye or say goodbye.
Bye.
Bye.
Good to see you guys.
Bye.
Bye.
Bye. Bye, Travis. Bye, Gus. Chuck, are you there?